Good evening, everybody, and welcome to episode 34 of Lore Lords, hosted by your boy Pat, that's me, and also Atlas tonight.
It's your boy Atlas here, and live Fortnite episode, finally here.
We're finally doing the Fortnite episode. No. Actually, it could be. I actually have no idea what we're talking about tonight because the title is simply just named Where Are They? And I'm like, that's pretty vague. Although the wonderful new piece of art that Melody has given us is very spacey.
Yes, spacey. Big galaxy vibes. You got some starry text for this one. You know,
yeah.
I feel like I like having episode titles like this because then people don't know what it is. Like the national parks was great because it was such a throw.
Yeah.
A couple people who I talked to who've listened to it have said that who have commented on that. It's not what I was expecting. It was much better. I thought it was going to be a very boring episode about parks, and they were very surprised that it wasn't.
I thought it was going to be boring as hell, but it turns out
it was. I was terrified. Yeah. So this is just called Where Are They? This is an episode I've kind of had in the back for a while. And I actually talked about it with you on one of your streams on Twitch a little bit. I remember I was about to go to bed and you started talking about this topic. And I jumped into your voice chat without asking.
Well, that's fine.
And
I'm in voice chat then.
And I was like, okay, listen. This is like, I was talking about this, it was late. I was a little intoxicated. But so I did this whole episode is basically about aliens.
Yay!
But like we did an episode before, the 66 Flap, which was about aliens in more of a spooky kind of cryptidy kind of conspiracy-y way,
Also, real quick plug, that episode is on YouTube right now.
Yes, if you go to YouTube, Anime Water, Lore Lords, I don't remember which episort number it is, but it's called the 66 Flap. It's another fan favorite episode. Like people really, I've been told a lot of people like that one. So give a listen to that if you can. This one is the opposite. We're looking at aliens from the exact opposite viewpoint, basically purely science-based. And
also, I just posted a link to the 66 Flap. It's episode 14.
Episode 14. Great episode. So this is all theoretical science today. I have about 7 pages of notes about it, but mostly it's just kind of like a discussion topic, like just what is this kind of stuff? What do astronomers and scientists today know about aliens? How to find them? How they want to find them? What they think about them?
How hot are they?
How hot are they? Can we breed them or do we put them in cages? Those are the only 2 options. Anyway,
Jesus Christ.
Sorry. If you're listening, aliens, I'm joking. I'm really nice. Don't do it.
He wants to breed you.
If you're a pretty alien and you want to come visit and like try some things out, like I wouldn't probably do anything against it. But like
kiss?
Like maybe give a big kiss. So this originally was going to be an episode just about the Fermi paradox, which I don't know if you've heard of that.
Yeah. We talked. That's what we talked about on the stream.
Yeah, but I kind of broadened it a bit to talk about some more topics in that vein. Things that are linked to it directly. And I wanted to start off by going over what is known as the Drake equation. Have you heard of the Drake equation?
No.
So this is the equation that a lot of astronomers use to find numbers on how much life is in the galaxy, kind of thing. It's a very popular equation used. If you Google it, you'll see the exact equation. Anyone can get a crack at it and try to figure it out. But the history of this started in 1960. There was an astronomer named Frank Drake who conducted a thing called Project Ozma, which was a multi-week long search for extraterrestrial signals using like big, radar dishes and stuff to try to find radio waves from Earth. Now, I don't know if you've seen those things. Like out here in LA, we have a couple SETI stations where if you go out in the desert, you can just see rows of satellites. They look like satellite dishes, Those things.
I have seen them.
Yeah. So this was an experiment that attracted a lot of attention, and Drake was told by one J.P.T. Perman, who was a staff officer at the National Academy of Sciences, to organize an informal gathering of accomplished researchers and engineers to discuss the prospects for finding a signal from an extraterrestrial source. So he was just kind of doing it on his own little project, and then it started getting attention. Because people were like, oh, this guy's kind of got some cool tech. He's got some cool ideas. Let's get on board. And so about a dozen people attended his big meeting at the Green Bank Observatory, which is where Project Ozma was being held. And the meeting was November 16th of 1961. And it included notable guests such as a biochemist named Melvin Calvin, who during this meeting got a phone call he was told he had to step out and take, which is when he was told he was winning the Nobel Prize for Chemistry.
Oh, cool.
For researching the assimilation of carbon dioxide in plants. So he was a pretty big deal in the science community, right?
Yeah, hell yeah, good for him. That's a good discovery. That's an important one.
Yeah, and so that I figured that was a good important guest to mention to kind of give credit to people here talking about finding aliens. Another guest that most of us probably know was renowned planetary astronomer Carl Sagan. Was also present for this.
I love that guy. Big fan.
Yeah. So Drake chose to organize the meeting around a new famous formula that he had conducted that was getting a lot of attention, which was made to estimate the critical number of SETI, which means extraterrestrials who are sending transmissions out, basically.
Sure.
The number of worlds transmitting signals in the galaxy was the solution to the equation, and this whole thing was like, let's just try to find a way to answer this, right? That was the whole mission of this meeting. Drake himself explains the equation in a way that we could all understand by comparing it to estimating how many students will attend a university, which you can use the same equation basically to figure out. And he stated that if you consider the number of new freshmen entering each year, like on average, and multiply that by the average number of years students will spend in school, being 4 years, you then have an accurate estimate of the total number of undergraduate students every year.
That's kind of cool.
So the Drake equation is, it's written like this. It's N equals R with a little star next to it, times F with a little P, times N with a little E, times F with a little L, times F with a little L, times F with a little C, and times L. So that was all those terms are, they're literal. Like the F stands for something, the N stands for, you know what I mean? They're very direct. It's
I'm
very
looking
easy
at it
to
right
understand.
now, actually.
Yeah, it's very easy to understand when you look at what they all mean. So the now famous Drake equation is constructed with the same logic as the college thing I just talked about. The first 6 terms multiplied together will yield the average number of new technologically transmitting worlds that came online in the Milky Way galaxy each year. The number known as the freshman rate is then multiplied by the last term of the equation being L, which is the average lifetime they stay on air. The result is N, which is the number of transmitting societies in the galaxy now. So this was explained to all these scientists at the conference, and they basically spent like a week working together, trying to figure out a way to come to an answer to this, determining what each little term meant and everything. Because they each mean something very specific, like I mentioned before, and some of which have to be guessed, such as the lifetime an alien civilization would stay on air. That's an entirely speculative, guess, because we can only really base it on ourselves, right?
Yeah.
And our own lifetime being on air is only like a century. So that's a pretty vast range of what it could be, and we probably won't be off air anytime soon. So that means if someone was very similar to us, they could be on air for 100 years, maybe 1,000 years, maybe 10,000 years, kind of thing. So they just kind of have to stick different numbers in there.
Because we don't know when they went online, because they could have started like 1,000 years ago,
exactly,
or Earth years.
Yeah, and it's been 60 years since that conference. And the Drake equation made its debut and made waves around the scientific community worldwide. There's consistently over 100 scientists today working at the SETI Institute, working on nearly 100 research questions at all times, which relate to one of the terms of the Drake equation. So, there's a bunch of people always working on this at SETI. And
that's cool.
SETI is now, especially now more than ever, with the recent, stuff that the Navy has talked about, and the UFOs and stuff like that. SETI has become a much more respected institute. Which is,
I bet for a long time people are like, "What a bunch of quacks, huh?
Yeah, basically,
a bunch of lunatics." And then all of a sudden it's just like, "No, we don't know what these UFOs are."
Yeah, and a lot of scientists and naval officers back until the this last couple years wouldn't ever talk about it, because if you did, you would just lose your job and your credibility.
Yeah, basically.
But now that the Navy's talking about, like, oh, we don't know what these are, these little objects, it's just kind of, people are more willing to talk about it now. And they just recently had one a couple weeks ago, a big conference on this, on the more recent sightings, where they just reiterated they don't know what they are. So, you know.
Yeah. No, I love that. Let's fucking go.
Yeah. Hopefully, disclosure's coming soon. Let's go. Everyone tell us what we got behind closed doors.
I just want to see some guy on a stage being like, all right, everybody, we have a lot of confessing to do. And then
this is my friend Bjorkton 6 from the 7th quadrant.
Yeah, exactly. And then he just walks out and just like, hi, guys.
He's just really rad little dude. He's like, dudes. He skates out on like rollerblades. That'd be great. I would love that.
I've been practicing skating to relate to your culture.
Check out this cool kickflip. And he just bails. Scrapes his knee. Everyone starts laughing at him, and then it causes a galactic war. The end of humanity. So, yeah, that was the first part I had written down, just on the Drake equation, what it is. And the second part I have is called Can It Be Solved? And this is actually kind of like when I started looking at the idea for this episode came from an article that came out like last week, but I had originally had this episode before that, like written down on my notes as like what I wanted to do, just based on the Fermi paradox. But there was a big article that came out on May 30th about this. So like just recently, like this year, May 30th, a big article came out. And before this article came out, on the same website, on June 15th in 2020, the American Astronomical Society had posted an article in the Astrophysics Journal, which is where I got both these articles from, claiming to maybe have an answer to the Drake equation.
Neat.
Now, firstly, it's important to note that we estimate that the Milky Way galaxy has 100 to 400 billion stars. Now, that's a pretty big gap.
That's a lot of numbers.
Yeah. That's a lot of numbers. And 100 to 400 billion is a big difference. So that's a big guess. But it's probably somewhere in between there. But that's just the estimation of how many stars we have. And the article makes a claim pretty boldly that they believe there is 36 intelligent civilizations in our Milky Way.
Cool. That's not a lot, though. But that's
not a lot, but it's a pretty big number of like species. Like think about like I don't know, like Star Trek. There's not that many nations in space, so I mean I don't know.
No, maybe. For real. My brain went to Mass Effect, but yeah.
Mass Effect, yeah, too. Even that, there's like what, like 11. So
yeah, something like
that. So the first of many assumptions that this article makes is that life would form in a way very similar on other planets as it has to our own. And by very similar, basically identical. All the research was done as if every planet was just Earth clones. Because we have no other numbers to go off of. But basing on that's the case, they say it takes around 5 billion years to reach the point we're at. And the next part is that they assume that the civilization would reach a technological point to transmit, and it would last at least 100 years like us. So they're saying that a star has to have a planet at about 5 billion years to even have the idea of having life on it, right? Like supporting life. Intelligent life, I should say. The data using almost identical data to like our Earth and our Earth's history, like I said, to plug in all these gaps in the Drake equation. The group was able to come up with an answer that there could be 36 active communicating intelligent civilizations in our home galaxy right now. So like there could have been more at some point, there could be more or less in the future, but like right now they think it's 36 people, 36 species of civilizations out there just broadcasting, right?
Right.
So this number depends strongly on how long they're actively sending out signals, such as radio from satellites like we are, which we've already talked about. Like that's a pretty big question there. The length that they're transmitting is the hardest one to answer, I think, of this entire situation. Sure. The three major factors to this answer are the histories of star formations, how common metal-rich stars like our sun are, and the likelihood of stars hosting Earth-like planets in their habitable zones. So by using that information and looking at things that are 5 billion years old, the answer is 36. So that's a pretty I think it's a pretty nice number. You know, it's not too crazy.
Yeah.
Because if it was too common,
it's
you know what I
believable.
mean? Yeah, exactly. Like if it was too common, we'd see it. But if it was, but it's 36 is a pretty good one.
Yeah, like if there were thousands and thousands of alien species, we would have absolutely discovered them by now.
Yeah,
Like,
I mean,
with 36, it makes a lot of sense. That's like, yeah, we just haven't really come across them yet.
yeah, they could also, if you look at how big the galaxy is, they could just, if they're like equally spread out, it would be tens of thousands of years probably before we even saw each other. You know?
Yeah, exactly.
So, unless we have like FTL travel or something, but whatever. That's a different topic for a different story. We are going to actually bring it up again at some point in this episode. Also, we're going to go in later into what you're talking about. How if there's thousands, we would see them by now. We'll talk more about that because there's some more stuff. But this estimation of 36 is a very optimistic viewpoint of where and why life exists, and it also has a huge margin for error. So the high estimation of 36, using their same answers, goes to like 18 million civilizations. And the low estimation is 1 on Earth.
Yeah.
So,
I had a feeling about that.
So it's like, it's got a big margin for error, 36, but they believed by those numbers they crunched as like the most common outcome. The lead author of the paper, Tom Westby, is an assistant professor in the Faculty of Engineering at the University of Nottingham. And he states that the classic method for estimating the number of intelligent civilizations relies on making guesses of values relating to life, but opinions about such matters vary quite substantially. Our new study simplifies this assumption using new data, giving a solid estimate of the number of galaxies being the number of civilizations in our galaxy. So, basically what I just said, he was saying that like they simplified it. They simplified the Drake equation to a way where they're just giving a solid number of 36. But again, they do put a lot of assumptions in there. They have to plug in some numbers. But basically, like based on those 3 major factors, 36. There are 36 aliens out there.
Well, if there's 38, I'm going to go to their little fucking space meeting, and I'm going to tell them that they're all goddamn morons.
Yeah, and probably at least slap one of them in the face. You led me wrong. And you give him a good old open hand slap.
How fucking dare you? Sorry.
Another thing the authors note is that the distance between these 36 civilizations and us is around 17,000 light years. So detection and communication would be impossible at the moment.
Yeah, no, that's the sad thing, the reality that I was, every time we talk about this, I'm like, yeah, that's probably most likely the case, is because even though we might, like, there might be classified information that we know of a civilization that's like, you know, a couple 100 light years away and they know about us, but we just have literally no way of actually communicating, which is like a kind of a bummer. It's like, oh, you guys are right there. You're right there.
So a lot of like alien conspiracy and stuff always assumes that we're on the low end of the tech scale and they're in the high end. If we're equal out there with other people, then we might never see each other. Also, like, unless, you know, right now, faster than light travel is science fiction.
Yeah.
But 100 years ago, air travel was science fiction.
Yeah.
So, like, you never know.
No, for real. I mean, there's a lot of, I'm not going to get into it too much because I don't know too much, but there's been a lot of, like, studies of, like, how to bend matter and, like, see if you can, like, get from one place to another instantaneously by not so much going really fast as much as you're bending space around you.
That's
you know
Star Trek plot.
Sure, but there's also people who like really. I mean, hey, they were probably inspired by Star Trek to try to do this kind of research. To be honest, because a lot of it starts off in that place.
There's that. What's that famous scientist? He's an older Asian guy with gray hair. Do you know who I'm talking about? He does like a lot of like TV shows and stuff, and he's like really like kind of plucky, kind of like energy. He's like, "Hey guys, we're talking about this." Anyway, he did a show.
I think I know who you're talking about.
Yeah, I can't remember his name, but he did a show a little while ago about science fiction in real life, and I remember watching the warp travel episode, and he talked about like the science that they use in Star Trek was the basis for all the science that they're using now to theoretically make warp engines, like in like
I looked
stuff
up
like that.
plucky Asian scientist, and I don't really think it gave me anything.
No, it wouldn't.
Unfortunately, I mean, maybe one of these people is the guy we're talking about. But
Let me see if I can find him real fast. Found him. Michio Kaku. That's his name. He's Michio Kaku, I think is how you say it. He's a cool dude. There's a lot of cool like sci-fi shows and stuff like that.
Oh yeah, him.
Yeah.
Yeah, I know exactly who
he talks a lot about that kind of stuff, and he was very big on talking about how he thinks warp engines could be real, and that would, gap the 17,000 light years a lot smaller.
Oh yeah, which would be so cool, but we're going to be dead by that time. Probably.
Hopefully not.
Well,
but you never know.
Not.
Could be 20 years. You never know what's going to pop out of somewhere.
Oh God, I'd love to. And then
yeah.
Sign me up. I'll go into space and never come back. Fuck you people on Earth.
Yeah.
I was kidding.
Let's go find those 36. Let's go find them 36. I'm leaving. I'm going to Mars with Elon. Anyway, another quote from a lead researcher on this paper, Christopher Consolis of the professor of physics at the University of Nottingham, talks about the length of intelligent species survival, which is, we were talking about earlier, the biggest what if. So his thought on it was searches for extraterrestrial intelligent civilizations not only reveals the existence of how life itself forms, but also gives us clues about how long our own civilization will last. If we find that intelligent life is common, then this would reveal that our own civilization could exist for much longer than a few hundred years. Alternatively, if we find there are no active civilizations in our galaxy, it's a bad time for our own long-term existence.
Yeah. I mean, you never know what kind of cosmic event's going to happen, and all of a sudden, boom.
Yeah.
In the blink of an eye, we're gone, so.
Yeah, or it's just like, maybe all species come to some self-extinction at some point. So, hard to say. But
I mean, that's definitely something I fear.
Yeah, basically this comes down to if we find aliens, basically we're like talking to ourselves like, oh, maybe we can reach that point. But if we never see that point,
yeah,
it's hard to imagine us getting to that point in our own.
Well, I could tell you something right now. If we keep valuing money more than we value our humanity's survival, we're definitely not going to make it that much further.
That's why I'm going to Mars with Elon. So basically, the
problem. No.
The other side of this coin is that if we never see or hear from aliens, it's possible that not only are we not seeing the potential in ourselves, they might live out there or exist out there at some point, but they might not last long enough to reach us. And there could be a couple sprinkled civilizations, like these 36. Maybe the universe keeps wiping one out and another pops up, and one wipes out and another pops up, so it kind of stays at a constant number. But
it's very stagnant.
Right? Exactly, but they never last long enough, so that's always a possible. So the second article came out in May 30th of this year, 2022, and it poses a very different conclusion to this first one. But before we go into that one, we have to talk about what I mentioned earlier, which was the original basis of this episode, which is the Fermi paradox.
Right.
So, if there is no clear, obvious evidence to extraterrestrial life, and various high estimates of people using Drake equation to say they're out there, where are they and why haven't we heard from them? This is what the Fermi paradox is. It comes from an Italian-American physicist named Enrico Fermi, which has his name associated with it because he was part of a casual conversation with a bunch of other physicists talking about a recent UFO report that came out and the possibility of faster-than-light travel, or FTL. And they were talking about this back in 1950.
Didn't Enrico Fermi also have something to do with the nuclear bomb or something?
It's possible. I didn't really look into it much.
I think Enrico Fermi has something to do with nuclear.
Yeah,
maybe it's not bombs. Maybe it's
apparently he was a famous physicist, so it's very possible. In the conversation when they were talking about FTL, though, he just said something along the lines of, "But where is everybody?" And that's where the Fermi paradox comes from. His name got attached to it because he's just the first person to be like, "Well, if they're there, then why aren't they talking to us?" kind of thing.
Because they don't like us.
That's a very possible answer. But there's two major parts to the Fermi paradox. The first, the Drake equation, which we already went over, And the second is the Great Filter. Do you know what that is?
I do not.
So this is a term you'll see a lot if you're looking into extraterrestrial search and like if you're reading science papers about kind of like looking for anything from UFO sightings to looking for alien signals or looking through telescopes. You'll see the words Great Filter pop up a lot. So the Great Filter is what prevents dead matter from giving rise in time to expanding into lasting life according to the Kardashev scale. So now what that means is this is commonly agreed as being an event called abiogenesis, which is what happened on Earth, which is the gradual process of increasing complexity between the first self-replicating molecules. So the idea of the Great Filter is something that's preventing nothing from becoming something, which is what happened on Earth. Eventually, just molecules are replicating, and here we are, you know?
Right.
That's called abiogenesis. So, also, I just want to take a little side trip to talk about the Kardashev scale, which I just mentioned. Do you know what the Kardashev scale is?
No, I don't.
This is actually talked about in Mass Effect. They mentioned the Kardashev scale a couple times. It's a measure of what level of civilization is out there based on 3 tiers made by a Soviet astronomer, Nikolai Kardashev, in 1964. So that there's 3 tiers of life. Type 1 is being close to a level of technology presently attained on Earth, usually defined as a civilization that can harvest the energy that reaches its home planet from its parent star. A Type 2 civilization is capable of harnessing the energy radiated by its own star, like the construction of a Dyson sphere. And then a Type 3 civilization has the ability to harvest the energy of this on the scale of its own galaxy.
Oh, wow. Okay.
So Kardashev believed the Type 4 civilization is impossible, which is an intergalactic civilization. However, some have proposed everything from Type 0 to Type 6. So the Kardashev scale, a lot of times, you'll see it go from 0 to 6. 0 being beneath us, and 6 being like a mentally transcended 4th dimensional being.
Yeah, I want to get to that point. Come on.
Yeah, let's be gas already.
I just want to be gas.
Yeah, I just want to be floating around in space as gas. So a lot of people on the big scale from 0 to 6, we're at 1.5. We're exploring our own our own system. And we have the ability to harness our star's energy on Earth. A Type 2 would be that we could go in space, basically, and build panels around the sun to suck up its energy to power our whole solar system.
I want to do that. We should do that.
It's probably, I mean, it's likely going to happen if we're going down this path. So that we're going. Eventually it'll happen.
Just giant solar panels floating in space with a giant wire that just goes down.
Yeah, that's it. That's
the Great Wire.
That'd be us being a Type 2, which would be great. I would love to get to Type 2 one day. So that's the Kardashev scale. So anyway, yeah, that's the Great Filter. The Great Filter talks about the fact that something exists out there that's stopping life from just being on every planet. You know, that's what the Great Filter is. It's just dead matter stopping from becoming living matter.
Kardashev?
Kardashev scale is the list.
Kardashev
is the scale of civilizations and their tiers in existence.
Right. Okay.
So
I just pronounce it right.
Yeah, I think it's Nikolai Kardashev, Soviet astronomer.
Gotcha.
So 2 astrobiologists named Dirk Schulz-Makush.
His name's Dirk.
Dirk Schulz-Makush, I think it's Makush, something like that, and William Baines came to the conclusion that events that happened on Earth to create life, from photosynthesis to tool-using intelligence, are likely to occur on any Earth-like planet out there, given enough time. They also argue that abiogenesis may not be the only Great Filter, but also a species just not having human-level intelligence and staying more animal-like, or the inability to settle other worlds due to their own self-destruction or lack of resources, is also a way to prevent communication. There is another major 2 parts of the Fermi paradox that rely fully on empirical evidence.
Right.
Which, we talked about earlier, we don't have any. One is that there is plenty of potential habitable planets, and that humans have seen 0 evidence of life when looking at it. When Fermi was around, the idea of many Earth-like planets was an assumption, but now with our technology, we know that the exoplanets are common. Like we've seen so many different planets out there, And the models used to predict a number inside the Milky Way go up to the billions that are habitable by humans.
That is pretty bonkers, wackadoo crazy.
Yes, there's a lot of there's a lot of different ways to say it, but like Star Trek calls them M-class planets. Exoplanet is just that supports life is just kind of the way that science classifies them today.
Right.
So there's that, but they're out there. Abduction stories and theories aside, we just don't have any evidence that you can go to look or listen to any aliens. You can't like Google search and find an actual 100% guaranteed piece of alien evidence. It's all theoretical or conspiracy theories. So there's a whole field of study for this. We talked about it today. It's called SETI. And it has been around for 40 years. It's had 0 results in all its 40 years. Any evidence pointing towards intelligence or extraterrestrial life.
Hey, 40 years isn't that long of a time.
I agree.
All things considered.
So. Yeah, a lot of people don't see that way. That we're just talking. We're on the same page. Right. Like in the large scale of things, like 40 years is nothing. But some people see it as like, oh, it's been 40 years. Like that's a whole lifetime. You haven't seen anything. It's like, okay, whatever. Relax.
Look, dude, we just did human flight in the radio like 100 years ago, so relax.
Yeah. There has been some astronomical discoveries that have been believed to be aliens, such as pulsars, which the stars, that's the type of star that like pulses.
Right.
Before we learned what they were actually called LGMs, which stands for Little Green Men. They're called LGM stars. If you look up LGM stars, you'll see a lot of it. But awesome. It's because when they pulse, it's a precise repetition. It's on a perfect repetitive state that seems impossible to be natural. Like it's too articulated. Cool. But now we've seen them through telescopes. We know what they are. It's just because it's doing perfect pulsing because it's just like a radioactive giant explosion happening.
Right.
So another way to see that people think might be evidence of aliens still to this day is there's certain debris that form around stars that people think are signs of asteroid mining. Like there's just asteroids that gather around certain stars or planets that have certain movement patterns that they don't think is natural. So that's always that possibility out there. Another large.
That's such cool, like outside of the box thinking.
Yeah,
like I would never have been like, oh, look for fucking asteroid mining.
There was one specific case I looked at where they were because I thought like, wouldn't it just be an asteroid belt? And they're like, we have an asteroid belt in our system. So I looked it up, and there's a lot of solar systems that have asteroid belts that they say shouldn't be there, like based on our asteroid belt. Like they're too close to a star to like be like where an asteroid belt would form, or they're put in a way that doesn't orbit correctly, and some of them even hit the star and like explode on impact kind of thing. Like so it's like it doesn't make sense that they're shaped that way. But of course you can also counter that with maybe some big asteroid hit a planet and it ripped open. That's just the left of it from like billions of years ago kind of thing. There's a lot of different things it could be. The third one is large spectral lines, which are, I think if you look up you can see pictures of them. There's just giant like ghostly lines in space you can see. And one of the theories is that it's nuclear waste disposal. Because that's how it would form in space. And people think that it's just like they look like trails almost like how you look up and see this we have very thin wispy clouds. It's like that in space, and a lot of people think they're nuclear waste disposal of different alien species, like dumping nuclear waste.
But I feel like there's a technology beyond nuclear that we're not considering. But
who knows what? Who knows what nuclear waste could even be used for in an advanced star-faring civilization? Could be nothing. Right. That could be low-end stuff.
They use nuclear waste to just make their food or some shit.
Yeah. It's just like their bathroom. So signs of evidence we are looking for are varied. One such would be an electromagnetic emission, such as a radio telescope, which many scientists have assumed is the natural technological advancement for any intelligent species. So that's the number one search for evidence, like we've talked about before, just listening for radio signals. Many scientists today spend hours upon hours carefully searching through near infinite radio waves hitting our planet from all directions in space, searching for non-natural emissions that may lead to the detection of an alien species, such as the WOW signal, which we're going to talk about a little bit later. Despite all this work at SETI, again, they have detected 0 signals that are not just random noise emitted from a natural source. Another would be the direct planetary observation, like how we see in space pictures of Earth from space with the lights on at night.
Yeah.
That kind of thing.
That'd be nice.
That'd be
the most surefire way.
Yeah, that's why these are the two number one ways. The number one, number two is someone's actually talking to us, or we just visibly look in a telescope and see like, oh, there's cities in that planet.
Oh fuck, that would be. Imagine. I just would love to. Oh god, I just like fantasize about imagine somebody like just looking at the right time in the right place, just being like, oh, holy shit. Holy shit! Holy shit! Like, who do you call? The president?
Yeah, I know. What do you do at that point? Like, I found him! I found him! Fuck! Call the paper, not the president. They'll hide it. So in 2007, an exoplanet was discovered to be in perfect range from its star for Earth-like life. And a new technology since then has allowed us to detect and characterize Earth-sized planets that sit in their star's habitable zones. So, like, we determined in 2007 we found a second Earth basically out there.
Right.
Like, it was a perfect planet for life. Like, it was Earth too.
I remember that. Yeah.
And now we can just scan stars and find them a lot easier.
We found a bunch now, haven't we?
Yeah, we've found a bunch. And the new James Webb Super Telescope, or the JWST, which is just going to start taking its next pictures like this week or next week, its first pictures, has the ability to glean some of this information from exoplanets in their star's habitable range, so we might get a lot more answers. And if anything we're going to
look at one of these planets, we're going to see like Neanderthal type people, and we're going to be like, cool!
Well, maybe not that close, but if they can see stars from space, like lights of cities, this telescope might be able to do it. So, could be huge.
Come on, baby, let's go.
Another theory, which is one of my favorite ones, of like a way to contact us, are brace wall probes. Do you know what a brace wall probe is? Because I didn't before looking at this.
No, absolutely not.
This is a theoretical technology. And this is a type of evidence for alien life. And what it is the idea of a self-replicating deep space probe from an alien species that would autonomously explore the Milky Way. And the reason why this is like an agreed upon thing to possibly exist is they would be able to communicate with other civilizations, unlike our probes, which just send out with a message. Because space, it's theorized that like if these probes exist, they would have an AI on board, and they would speak to another species on behalf of their species, because it would be crossing a distance of light years, like we mentioned, that we just can't talk across. Like it'd be just too far to send a signal. It would turn into nothingness by the time it got there. So the idea of a Bracewell probe is like it's like a probe that goes as far as it can, right before it dies, it rebuilds itself and goes again.
Ooh.
And it keeps doing that over and over again until it finds something, and it says like, "Hello, like I'm an AI from Earth." Like
that's how you make a Reaper, though.
Yeah, 100%. That's 100% how you make a Reaper. So our current exploration of the solar system has yielded no results, of course, to finding something such as a Bracewell probe, attempting to signal us or attempting to attract any of our own probes, like that, you know.
Right.
So but it's a theoretically agreed upon like science, like technology that could exist. So the last on this side of like tech looking for aliens would be a stellar scale artifact. In 1959, Freeman Dyson observed that every developing human civilization constantly increases its energy needs, and therefore its consumption of energy.
Yeah.
He is credited with the creation of course, the very famous Dyson sphere idea, which would be a superstructure that would form a shell around a star to absorb and utilize as much possible radiant energy as possible. This would be such a feat of astroengineering that it would change the way we would be able to see a star from a distance, and we would be able to detect its existence. So there has even been multiple stars that have been seen dimming, and like dimming in weird ways, like almost unnatural patterns. And some scientists do believe that we're looking at Dyson spheres that are just too far away for us to look at, but they go like in and out of light, like in a weird, infrequent way that a dying star wouldn't do.
Would that mean that Starkiller Base was kind of a Dyson sphere because it sucked up stars and shot them?
I mean, kind of, but a Dyson sphere is usually, it's like you were talking about earlier, like building a solar panel in front of a star. Think of that, but fully encompassing it, like a giant sphere made of nothing but solar panels built around the sun, like encapsulating it. Yeah, well, exactly. They would have like windows. That's what people think the dimming we're seeing is, like the light coming out of these spaces to keep light in the solar system.
Right.
In 2018, observations determined that the amount of dimming pointed out could have just been dust. excuse me, rather than an opaque object as a Dyson sphere. So I think it could be like dust or clouds of dust.
Yeah, that makes sense too.
In front of it, that's making it like harder for us. It would cause it to look like a dimming effect, maybe like a cloud on a lens kind of thing, you know?
Yeah.
Many scientists use the Fermi paradox along with other forms of searching the stars to come up with hypothetical explanations for not only the paradox, but why we have any contact at all. One of which is simply the rarity of intelligent life. Like, we talked about that before. Many scientists pose that extraterrestrial life very well may exist and probably does, but it doesn't mean it's intelligent either. There could be entire planets with full ecosystems running wild, but no intelligent species, such as humans, around, which was the case for Earth in the millions of years ago in the dinosaur ages. Like, there was no intelligent life, which is the wild animal. Like, aliens there could be species back then who were trying to do what we're doing now. Like, why is no one talking to us? Thinking there's no aliens out there, not knowing that we had this giant planet of monsters,
Which is really cool, but you're right. Yeah, there's no goal of the planet. It's just kind of like
it just exists as exists as an ecosphere. That's all it is. Just an giant ecosystem all around everything. And if mass extinction event never happened, intelligent life may never have risen on our planet because there might not have been a reason to.
Yeah, we would have just kept getting eaten.
Yeah, if dinosaurs were so dominant and just stayed dominant, like nothing probably would have happened. Like mammals would have stayed small little rats underground. So
probably, yeah.
Another theory is that it's simply non-existent and we're the only intelligent life out there. As life itself may just be a super rare fluke of chemicals meeting in a very specific situation, and an even more rare situation would be that it eventually evolves into intelligence, such as humans, because again, like we just mentioned, there was life, and now we have intelligent life. So there's a high chance that intelligent life just never happens. There could be plenty of alien animals out there, but there might not be any alien intelligence out there. There's also the thought that if there is intelligent life, they may never create advanced technologies or even care to explore. It's very
I find that hard to believe.
Yeah, but I mean, again, alien, we just don't know. They could have a completely different wiring where they just don't want to explore, or they could have a completely different wiring where they just stay in a more primitive style of life, like a tribal society, and they remain that way, or they just don't have enough advanced intelligence that's their peak, The other side of that coin is that they do, but it's simply the nature of intelligent life to destroy itself. We right now, us humans, have plenty of ways to kill ourselves, such as nukes or many other military weapons or viruses and stuff like that. The chances are pretty high that another species out there would reach the same level of technology, such as splitting the atom, and there's a much higher chance that they would have either nukes or some analog to nuclear weapons. And they would, hit the button, which we managed to not do in the Cold War. They could have their own Cold War and then hit the button,
Right.
Two famous astronomers, Carl Sagan and a man by the last name of Shlistovsky, in 1966, speculated on this topic, saying that technologically advanced civilizations who reach a level of developing interstellar communication will either destroy themselves within a century of doing so, or master their self-destructive tendencies and survive for billions of years that just keep on rising.
I really hope we're that second one.
Yeah, well, I mean, we're almost there if that's the case. We're almost at 100 years of nukes, so hopefully.
Yeah?
If that's the case, we're good. There is also the idea how aliens would behave. It's thought that aliens would only broadcast for a short time due to them outgrowing radio technology, or having moved on to something we cannot detect yet.
That's what I think, to be honest.
Yeah. Alien life may also just be, too alien. It's possible that aliens could be so different from humanity that we simply can't speak to them in ways we know. They could develop entirely different technologies or techniques to communicate or even explore space in ways that we never notice or even think of them being life.
Right.
Like, what if the asteroid that came by, what if Halley's Comet is a rock person's scout ship?
Yeah, that's a good point. And they're just checking shit out. And they were like, oh, these weird squishy things on this planet.
Yeah, or they just don't even recognize that they have weird squishy things on their planet and they see us as just plants, or rocks.
Yeah,
the opposite, It's like there's so many ways that we could just never see each other. Another similar idea to this that I saw was virtual reality civilizations, which was a crazy theory that I've seen a little bit of talk of recently. I think it's a newer theory of a civilization that basically exists only in the form of entertainment.
Like the meta universe that Mark Zuckerberg wants us all to live in.
Yeah, exactly. Like, imagine that just kind of like was a whole civilization, and you lived your life plugged into a machine, and just
Like
you even could explore the universe that way. You could control craft plugged in through your virtual reality thing.
That's kind of where we're going IRL.
So it wouldn't be the worst, but as long as you can take the plug out. Like, I don't want to like be in there forever. But I mean, exploring via VR isn't that bad of an idea. That's a great idea if it's possible.
That's like that live forever type of shit. It's like, no, I want to die. Like, I don't want to live forever. That sounds awful.
Well, what if everyone lives forever?
I still probably wouldn't like it.
All right, I'll just take you out. Don't worry about it.
Thanks.
So another good bunch of theories about why we haven't seen people is just economic reasons. Maybe it's just too expensive to be constantly reaching out or exploring space.
Okay, but to be fair, economy is a choice. Just saying.
Well, I'm not talking about money. Like, there could be literal material limitations to doing such things.
Oh, that for sure. For sure. That's why we need to go to other planets.
It doesn't have to be just the economy of trade and resources just in general. Like, if they mined out all their metal.
Sad.
Like,
my brain is just so sad and annoyed with money economy that when I hear that word, I'm just kind of like, who gives a fuck about the dollar?
And some species may be on much more resource limited worlds, and they can't afford to have massive radar arrays like SETI and listen to or broadcast out signals. Like, some planets might even be like super small. Like, what if aliens lived on a Pluto-sized planet and they only had a population of 10,000 people, and to them that was a lot of people?
Or like King Kai's planet.
I mean, that's probably a little too small. But let's say we're really tiny,
A monkey and a cricket can live there.
So. They could be tiny little small. They could be like microorganisms. That's possible.
That would be cool. That would be really, really cool.
And the third thing is colonization. Might just be too expensive because I mean, in our world it is. Like, not just. I mean, money is of course a huge factor of it, but resource wise too. Like, that's a lot of fuel. It's a lot of food. It's a lot of metals. It's a lot of plastics. It's a lot of shit.
Medicine.
Medicine. A lot of stuff to go colonize at Mars. Like, that's a lot of shit. Which I do think we could get there one day. I don't think it'll be 2050, but Elon. Anyway, so that could also just not be the norm for species. Species might be very aligned in their idea of not wanting to explore, like we talked about earlier, or not wanting to leave their planet. Like, that could be a very unique human trait for all we know, that we want to do all this shit.
Right. I just find it hard to believe that people don't look up and go, "What's that? What's up there?" Like, but you're right.
They could look up and be like, "Oh, scary," That could be
that's what my cat does.
Exactly.
If I take Marcy outside sometimes, and I just kind of like walk around the balcony areas, and she just kind of like, she's like, "There's no roof."
Right. Like, that could be an entire. If cats took over instead of humans, that's how maybe they would think. So also, discovery of alien life might just be too difficult for what we have today. It's entirely possible that we just haven't listened long enough or not properly. SETI programs may cause searchers to miss signals that are present, as alien species may transmit signals that have a very high or low data rate, which on SETI regulations that they have, SETI regulations that they have, they don't really pay attention to those because they don't consider them normal.
Right.
Like, we have our own like mid-band frequencies that we use, but there could be aliens that use high or low band normally. So like, they could be broadcasting on that, and we're simply just not scanning those signals a lot. So there's low priority star systems out there too that could be sending frequencies that we don't listen to because they're not orbiting a sun-like star. So there could be species that evolve in different paths, like we talked about. We're assuming a lot of things are human. Like, humanoid.
It's very interesting too to consider on an evolutionary standpoint is like, planets have cores. Cores are hot. A lot of species could be developing underground, and they could be orbiting stars that just aren't bright enough to to give them the necessary nutrition on the surface, so they have develop underneath.
That is literally the next point that I have written
great.
down.
Nailed it.
Yeah. Aliens living under their planet's surface or under their planet's oceans or live on a world fully ocean, kind of like Europa, would be hidden from our views. If a species lives under the surface of an ocean-like world, then we would not be able to see their lights from space, and they would have trouble communicating because their frequencies would be way different to be able to pierce the water. And subterranean again, same idea. Way different frequencies and tech to kind of like pierce that barrier, that physical barrier between them.
Imagine a planet of technologically advanced Zoras. That's cool to think about.
Yeah, I think it's very possible to have aquatic species. There's no reason why not. I mean, there's so much life in the ocean.
In the water.
Yeah, right, but if there was no land to go to, I feel like intelligence could. There's very intelligent, dolphins and stuff. So like they definitely could grow into more, intelligent life. Another possibility is they might just be aliens could just be too far away, and like basically the Bracewell probe, what we mentioned earlier, would be the only way to communicate them. If species are several thousand light years away from each other, it's more likely that the species will go extinct before being able to send a message to each other. So, there's that.
Sad.
Yeah. Another is the zoo hypothesis, which states that intelligent life exists and knows about us, but does not contact us simply to allow us to naturally progress.
That's my theory.
To either our self-destruction or our eventual rise to their level. This is the Star Trek way too. That's how it was in Star Trek.
It just seems so logical to me.
Yeah, no, it makes sense. I mean, if they're watching us, like these UFOs are all UFOs and stuff, it's very possible that's why they're just like leave them be. But we're still gonna like study them. Maybe they're filming nature documentaries on us. Who knows? So the last thing I will go over here is, which is my least favorite to think about, which is the theory of "shut up, they will hear you." Which basically means that something out there has scared everyone into silence, and we just don't know about it yet. This could be a certain civilization, like Star Trek's Borg, that just endlessly destroy and absorb life, or maybe it's something from an entirely different galaxy, like a Reaper or something that we just can't communicate with, and it exists only to destroy, or eat, or consume. Right. That's a very possible answer, and other people have seen it or witnessed it, and they just stop broadcasting because they don't want to get caught.
Yeah, I mean, the Reapers are one of the scariest things in at least video game lore.
Yeah, it's and like in Warhammer, there's things like the Tyranid, which are a hive mind of organic aliens that live in between galaxies and just reach into galaxies and eat literally everything. Like that kind of thing is, who knows? Maybe it's out there. But yeah, that was all I wanted to go over for that. That's like the Fermi paradox and the things, how people try to look for empirical evidence and theories as to why we haven't had any empirical evidence. So, that's all reasonable. I think it's a pretty reasonable way to look at it. Again, purely science. This is all like science and theories. There's no, but I saw lights in the sky talk. This is all assuming none of that's real. None of that's a thing.
Right. But I did see lights in the sky.
A lot of us have seen lights in the sky. So I want to go over the article I mentioned earlier, which is inspired this episode to kind of be made. It was posted to Forbes by Jamie Carter on May 30th of this year, and the article is titled, "There Could Be 42,777 Intelligent Alien Civilizations in the Milky Way."
That would be fucking wild.
So, that's a lot of numbers. And the article references a paper published to the Astrophysics Journal on April 4th, titled "The Number of Possible SETIs in Our Galaxy and the Communication Probability Among the SETIs." The paper basically states that there's likely to be 42,777 species in our galaxy capable of communicating with us. And it even goes to detail, using the Fermi paradox to help come up with the answer. It also looks at how probable it is that one of them could contact us and when. And there are huge unknowns, of course, again, behind the seemingly very precise estimates that, if known, would make a massive difference in the results, the two of which being the probability of life appearing on rocky planets eventually evolving into civilizations, advanced enough to make contact, and then at what stage of the host star's evolution such advanced civilizations would be born. So, the figure of 42,777 is very high, especially compared to the 36 we were talking about earlier, which they seemed pretty concrete on. And now that number has drastically increased. But there is an error rate. But the error rate on this one, unlike the other one, which was millions, they claim is only a few hundred. But this is what's known as an optimistic estimate. When they're doing this work, there's always two estimates: the optimistic estimate and the pessimistic estimate. So the optimistic estimate is the 42,777. This is based.
That's a bunch.
It's a lot, and this is based on the estimation that 0.1% of civilizations that would exist are advanced enough to contact another civilization. So that's saying that there's a lot more out there, but only 0.1% can contact each other.
Right.
And this is where the great filter we mentioned gets brought up in this paper. It talks about the fact that why would all that 99.9% not get to high enough stuff? Would they remain cell stage creatures? Would they remain, just multiplying atoms and never actually come to anything? Maybe
they nuke each other.
Yeah, that would be a little further in that along that technology, but the same answer. Like they just end each other, or they just stay tribal. That kind of thing.
Yeah.
It goes over that each civilization would need to survive for 3 million years to reach the point of being able to communicate. So, assuming that's the true number,
that's a little bit of
we're a drop in the bucket of 3 million years.
Yeah.
If a message is sent to us from an advanced civilization in the Milky Way, the question remains as to whether humans can survive long enough to receive it. The authors of the paper suggest that we will need to wait as little as 2,000 years, however, to receive our first signal. So,
only 2,000, huh?
Yeah, so they're saying a civilization has to live 3 million years to start sending out signals to other things that can be answered, right? So if this started, 2,999,000, or 998,000 years ago, we only have 2,000 years left for the signal reaches Earth, kind of thing. So, that could be our first contact. So, again, that was the optimistic part. And the optimistic part is assuming the 0.1% of civilizations would become advanced enough to communicate with other planets. They also came up with the answer on the other side of the argument, the pessimistic estimate, which is that 0.001% of civilizations, about 111, would be advanced enough to communicate. So, even on the low estimate of their thing, that's higher than the 36 that we had before.
That's still, yeah,
at 111.
Quite a bit.
If that's
the number just keeps getting bigger.
Yeah, the more that we learn about space and the way things are set up, the bigger the number gets, which I don't think is coincidence.
No, I don't either. Yeah.
If that's the case, that means that we would have to wait around 400,000 years to receive a message.
Okay, let's do something. Okay, let's jump into kind of like let's even take these concepts that we've been talking about and broaden it even further. So when it was 36, when the number was 36, the estimate that we'd be able to communicate with people at all, or other civilizations at all, was still basically a null and void concept. Now it's, what was the percentage again? That low percentage? It's just like
0.001%.
Yeah, 0.001%. So now it's that. Now, see, to me, it just, all of that seems like it's so mathematical to the point where they're missing the greater point, which is I don't think that it at all would take us that long to another 2,000 years. I don't think it would take that long at all. I think with everything that we're doing, it could take us as short as a couple decades. You know what I mean?
Yeah, again, so the year estimate that they're talking about isn't our potential to see an alien, basically. It's the literal distance of sending a message light years and receiving a message light years. So this is assuming that nothing can fly out to us, right? This is assuming that they sent a radio signal we have. We've sent radio signals out. We sent out the Araceli message. We have messages out there but it's that could take 400,000 years to reach the alien world that we sent it to.
Yeah.
That's kind of what they're saying. So it's that's assuming they have to do that it could be that long for us to just receive it to say you've got mail.
Right, and I get that, but I think that again, we're dismissing the fact that we discover new technologies almost every other year. And that's what I think is really the case, is that radio is great, but radio is probably primitive. The same way that I think that that like the way we do warfare, before we used to use bows and arrows and swords, now we use guns and bombs and nukes. One day it might be cyber warfare. One day it might be, something else.
Yeah, like, no. I get what you're saying,
know.
And I'm sure a lot of these people think the same way, but they can't say that because this is a science paper. You can't just make up sci-fi tech for the science paper. But I do agree.
That's true.
I think there is I think radio is probably primitive, and it's very possible that radio was our first. We don't use radio waves a lot in life anymore. It's just in space. It's how you punch through all the layers. But of course, it could be a more advanced way to do it that we just don't know yet.
No.
Wi-Fi in space. I mean, honestly, maybe. So yeah, the last number I said was they think it was 111, 400,000 years to receive a message. All those thousands and thousands of light years across the galaxy. This is also assuming, with the way they're mapping out the galaxy, that these 111 species are equal distant from each other, like around in a grid. For all we know, one could be right fucking next to us. Like
which would be probably pretty cool.
That would be pretty cool. Hopefully,
as long as they're not mean.
Please don't be mean. Be Asari, not Klingons. So the author of the paper, Wenji Song and He Gao at the Beijing Normal University's Department of Astronomy, did mention that the pessimistic number of 0.001% may even be an overestimate. If their quote was, if so, the number of cities would become even lower and the opportunities for communication between cities would become extremely small, which is a more common number upon more recent papers, which I think they're referencing the British paper we talked about earlier.
Right.
They just don't directly say it. So the WOW signal is a very famous signal that was picked up from space in 1977 at the Big Ear Radio Telescope in Ohio by astronomer James R. Eman. Have you heard of this?
No, I have not.
Okay, so it was a signal that showed up that lasted 72 seconds, and this guy wrote the signal down as it showed up and wrote WOW next to it with an exclamation point, which is why it's called the WOW signal. So the entire duration it was recorded was 72 seconds, and which was as far as you could record at the time. And it was completely unique and it came from the constellation of Sagittarius, which is likely where many astronomers believe aliens would exist because that's kind of the core of the galaxy.
Right.
Where stars are a lot closer to each other. And if it has ever been detected, it has never been detected or observed since. And unlike all other natural signals picked up, it's not to say that means it's aliens for sure, but to this day, we still don't know what this signal was. Because the signal came through basically pinging frequencies and we're making little pings. I don't know how you even describe it, but a different signal came through than we normally get from background radiation. And the guy listening immediately, when they listened to the recording, he heard it immediately. It wasn't they had to search for it. It was immediately noticed, whoa, what is that on the recording kind of thing.
It's aliens.
Yeah, but I'm sure that's what he thought for sure. Yeah. But yeah, it's never been repeated since. So it was a completely unique radio signal that came through.
Yeah, it's aliens. It is.
The source of the signal is unknown, but a recent paper found only one sun-like star, named the very easy-to-say 2-mass 192819822640123, in a sample of 66 stars in the region that the WOW signal came from, and it's 18,000 light years away. So they think that's maybe where it came from, because it's the only sun-like star in that area. The last thing I said was the name of the planet. I don't know if I got to say the whole planet name, so I'm gonna go ahead and say it again because it was really attractive.
Right. Yeah.
The WOW signal came from one planet, which is said to come from a signal. The was traced to one sun-like star, and the planet around this star that it could maybe come from is called 2-mass, MASS, like Massachusetts. 192819282260123.
Oh, just call the damn thing Fred or something.
Right? It's really, you have a famous signal from it and you haven't given it an actual name yet?
Yeah, seriously.
That's insane. So another 2012 paper on the Drake equation estimated the closest possible life following all our own rules is 1,933 light years away, which that would take a long time for signal to get to, probably 1,000 years.
Right.
But, yeah. So there's that. In 1974, we sent out the Arecibo message, which was basic information about humanity and Earth. You've probably heard of this before.
Yes. I've heard that one, yeah.
We sent this out to Globular Star Cluster M13, and this was meant to be a demonstration of how far humanity has gone, rather than a real attempt to enter into conversation with extraterrestrials. Like, this is just like, hey, look, we're humans. We can speak in space. It wasn't actually like a communication thing.
Impressed?
Basically, that was what it was. The author of the paper states, if there are indeed SETIs in M13, their detection abilities need to be 21 orders of magnitude higher than ours to even detect our signal. Conversely, if they transmit a similar signal, we need to improve our detection ability by 21 orders of magnitude to detect theirs.
Okay.
You know, basically, like, space is huge. That's the bottom line of this whole episode.
Yeah,
and we may never find anything. I think it's likely we will. I think it's likely we will or have. I think it's likely that they just shut this episode off in the middle of recording because they knew we were talking too correctly about what they were going on about.
Yeah, I said in the chat on the stream they didn't like us talking about the WoW signal.
They know about it. Turn it off. We're the famous Art Bell call that got cut off from Area 51. That's us. We just reached that level of fame. Get ready.
Yeah, guys, with that level of fame, all 13 people watching.
Yep. No way. They're gonna hear about this recording and be like, "Oh shit, dude!" And they're gonna crawl in. So yeah, that's basically what I have today as far as like the paper goes, like the sciences and everything about it, like all the numbers and stuff out there. And yeah, basically we just, if you look at like actual astronomers and their opinions, it's what I just talked about. Like, a lot of them do agree that there's aliens out there, but it's just going to be a while till we hear from them. Right. Unless, of course, you know, government disclosure, Injured Cold comes down.
Yeah, exactly. Injured, I'm telling you, man, reach out. I'm right here, bud. But no, well, that's fantastic, by the way. This is what I'm glad you brought this to us, because I love alien stuff a lot, because again, I really think it comes down to our level of technology. I think that like the more we advance in space and communication technology, I really just think that like it'll expose more, it'll show us more, and we'll be able to reach out. Like, again, we're using forms of communication like radio that's pretty old. You know, I mean, it's great. It served its purpose, but like, we should be trying to find different ways of communicating. I don't know how. I'm not a smart person. I studied music in college, so I can't do it. But like, you know, but I just, it's that kind of nuanced thinking that I think is really important. Like, it's very important to have all these numbers and equations, and it's really fascinating. But at the end of the day, it's like, yeah, but you're only measuring it up to what we have here on, like you actually said at the very beginning of this episode, it's all relative to us. Like,
yeah,
it's all relative to what we have.
There's a whole another side of what you said too. Like, I agree. Like, I don't think radio is the definitive technology that we're going to be seeing aliens with. But I also like to imagine that other aliens, like I kind of mentioned, there might be rock people, there might be gas people.
Yeah.
Not necessarily carbon is the only way to support life. That's just what a lot of we know because it's our existence. But there could be, it's aliens. Anything's possible in aliens. You know, almost like we just don't understand because we don't have any evidence.
Right. Except for maybe things that have been hidden from us.
Yeah. But I mean, like, it's like even then, like, there could be gas giants full of life that we just don't think is possible because we just think of that as impossible, but it might not be impossible.
I really do think that a big problem with, like, because I think that our authorities, not just in America, but in other countries too, especially ones that are more advanced, like China and the UK and stuff like that, I really do think that there are like, they know stuff that we don't know, and they don't want to share it with us because of our culture. Entirely down to our culture. Like, and I think that that's kind of why a lot of things are kept from us, to be honest.
Yeah. Also, I mean, I don't know. There's a lot of stuff now. I mean, just a lot of, like, you know, the U.S. is holding conferences on UFO sightings. Like, that's crazy. That's crazy that United States Navy generals got together in Washington, D.C. and held an open press conference about UFO sightings, how to report them, trying to urge other military officers who have seen things to talk about it. Like, it's okay to talk. They even said, like, it's okay to talk about it now. Like, you were not going to be thought less of. Like, tell us what you see. If you have footage, bring it to us. Like, let us know so we can try to figure this out together, kind of thing.
Right. Yeah, and I think that's honestly, I think, a huge step for that cultural shift. Because, like,
Yeah.
again, I think a lot of us in general, and I don't say this, I really don't, and I know it might sound like I am, but I'm not saying this in some kind of condescending or patronizing or like, hateful way. But I think a lot of people are more obsessed with the ideas that are very like, I don't want to use the word religious, but in that context, I guess, like, oh, we were made by a magical entity from space, or not from space, but from like, heaven and that kind of thing. And I think that if you told that some of those people, hey, there's an alien species that's, a couple solar systems away that want to come and chill with us, that would break them. You know what I mean? That would shatter their worlds, and they wouldn't be able to recover.
There was
from
a recent article I saw about how the Catholic Church did surveys in America about how people would feel if they discovered alien life.
Right. I remember we talked about it. We may have talked about this on my stream or on another episode.
Yeah, but the answer, it was positive, though. Almost all of them were like, yeah, I'd be fine. I get it.
Yeah, which is good. Which is a very good thing to hear, because, like, although, it's funny. I honestly think that one of the big problem nations would be America, because I think that we have the type of people who are like, the type. I'm not gonna try to pigeonhole them too much, but like
they go to rallies in the capital city.
Yeah, exactly. It's the same kind of mentality of like, like white supremacists would have a big problem with this.
Yeah.
Like, you know what I mean?
Imagine, like, I can see in the news now, like, they're not real. They're government experiments coming to visit us that they put out into, you know what I mean? Like that kind of thing.
Right, yeah. Like, they've been doing government experiments up in the satellites, and they accidentally, one of them got out and landed on planet Earth. It's like, okay. But yeah, and also, not everybody who thinks that way has that type of accent. Some people who have that accent are really nice people. But
it's it's I think if we know about them, I do think it's the time between it's publicly talked about is getting shorter every day.
I do. I agree.
I
really do think. I think in the next 10 years we're gonna have genuinely some type of like confirmation of, yeah, we know that there is. You know what I mean? Not that we can communicate, not that we have anything else, but we'll metaphorically speaking, we'll see the lights on the other planet. You know, like kind of what we were talking about. Like, I think in the next 10 years we can have that. I really do. Because I either think that it's already happened and we're just keeping it away from people, or we're genuinely on some kind of brink. Because, like, again, our technology has grown so much in the past. Just since I was baby in the 90s to now, it's like, it's insanity. We used to carry around CD players. They were tiny. They were like hand-sized things that would put a disc into it, and it would only be able to help you listen to 13 songs. Now we just download it on our phones. Like,
or not even. Don't even download it. You just walk into a place and all of a sudden you just can receive it. You know?
You just like, get it. Which is, by the way, ruined the music industry.
Well, that could be your next episode.
Summed up.
But,
I was going to say, I could sum up actually, that would be a fun Lore Lords, the technology and music episode. That would be kind of a fun one.
Well, I think that's all we got for today's alien episode.
Great.
Space episode. And
Love space.
Yeah, it's a great topic. We'll be back there again. This is probably the only time we're going to go like super sciencey with it.
Thanks again, guys.